So today I'm here to talk about advanced interlayers for laminated glass applications. Although laminated glass has been in use in the industry for quite some time, um, but it's a fact of the matter that all laminated glass, they are not the same, because what goes inside the two layers of the glass can actually influence the structural behavior of the glass to a large extent. So in today's presentation, we will see that how the type of interlayer that has been used in between the two glasses that influences the different performances of laminated glass. Yeah. Okay, so before that, I would like to make a quick introduction of what is Kuraray and what we do. So Kuraray is a Japanese multinational chemical company, but having its footprint all over the globe. So we have 7 manufacturing sites and 2 R&D labs and 18 sale office all over the world. Yeah. And in the advanced interlayers vertical of Kuraray, we manufacture a variety of interlayers for different applications. So starting with the most standard application, which is a safety glass. So we have Trosifol clear and ultra clear. These are the interlayers that we recommend to use for when you just want to make the glass a safety glass. And then we have for decorative, acoustic, structural, and security. And there are some specialized applications as well. I'm pretty sure you are already aware about some of the product names already. But very recently, we have added a new product into our kitty, which is Trosifol bird secure or bird friendly glazings. So this is an interlayer which can be used for such applications. And in today's presentation, I will have a special focus on this particular product that we have introduced in our kitty. Yeah. Okay. Um, so moving ahead, I think in the previous presentations, we have seen that how the importance of glass is increasing day by day, and in the past few decades, we can see that there is no building which is not making use of glass, and it's hard to imagine any building these days uh, without the use of glass. Because of its variety of reasons. I mean, we have seen. Glass has become an integral component of any modern building because of the variety of benefits that you get from the properties of the glass. But it's very important that you select the right type of the glass, unless otherwise, you can the whole project can actually go for a toss. So why I say so? Just to emphasize on this, I would just like to play a small video over here. Um, I have played this video at previous events as well, but I think it's very important to keep on repeating the message that we want to spread here, because toughened glass or tempered glass, as it is called in different countries, is considered to be safety glass by the country standards, even in my country, India. And so I think it's very clear that if although toughened glass is going to break in small pieces, but if it is falling from a certain height, it has this a great amount of potential to injure the people underneath. So you can just imagine if you are just walking besides such a glass railing and glass is raining down onto your head, it can be fatal. So you may recall this slide, which the previous presenter Nisha Gopal also presented about, that if you, change the breakage pattern of the glass, that also helps in achieving the desired degree of safety that you can get from the glass. And of course, in this case, you can see if the fragments are getting smaller for tempered glass, it is definitely improving the safety, but not necessarily it could be an absolute safety glass. So we can say that laminated safety glass is the most safest type of the glass. But having said that, it's we must remember that what it goes inside the two glass layers will actually influence the especially the post breakage performance of the glass. And also it's important to highlight that the temperature and the duration of the load will have a big impact on the post breakage strength here. Quite often, these are the two parameters which are not taken into the design considerations. I think with the growing awareness that has come up in the recent 2 decades, now it's especially the ASTM 1300 and some of the European standards. Um, they have made provisions for consideration of the temperatures and the durations of the load, because they have a significant impact on the shear modulus value of the interlayer. Yeah. Okay. Then moving on, the different applications where you may have to use laminated glass. These could be safety, structural, acoustic, and bird secure. This is a new introduction into our kitty. And security applications, cyclone resistance, and decorative. Yeah. So in today's talk, I will touch briefly all the applications. I think in the interest of time, maybe we won't be able to go into much details of each application, but I'm definitely available if you have some specific questions related to any of these segments. You can always reach out to me. Yeah. So let's start with the safety first. So this is an extract that I have taken out from the IS 16231 with part 4, which is an Indian standard for the use of glass in buildings. It is related to the human impact on the glass, and also it is a part of the National Building Code of India. Although it's a standard from India, but I think it's very much similar to the other country standards, which make it mandatory that whenever there is a overhead application of the glass, I'm talking about the case number 4. So the application could be skylights or canopies. There it is mandatory to use laminated safety glass. And the case number 5 is when we have glass railings, then the use of laminated safety glass is recommended. If we talk about case 3, the vertical applications, here it's a recommendation to use laminated glass, but it is not mandatory as of now. But in some countries like Singapore, it has become mandatory to use laminated glass when are using from a certain height of the building. Yeah. Then for a standard application where the intention is just to make the glass laminated safety glass, so there you can use our Trosifol clear or the ultra clear, depending upon what type of glass you are using. Yeah. Then we talk about structural applications. These are the applications where the glass is acting as a structural element just because of the reason it is minimally supported. It may be supported on point fixings, as you see in the picture for the glass railings, or it could be a glass flooring where people are standing onto the glass surface, and it is supposed to sustain a considerable amount of the live loads to which it is getting exposed. For such applications, we recommend to use our structural interlayers, which are Sentry Glass and Trosifol ES. So I have a video over here. So let's see how it behaves when a PVB laminate is broken. So in this case, you see it's a cantilevered glass which is supported only at one edge, and we break both the glass layers and see its post-breakage strength, how it is. And this test is being conducted at room temperature conditions in somewhere close to Berlin, where we have our manufacturing facility in Troisdorf in Germany. So you can see, Europe has a climate which is much more moderate compared to the climate conditions in Asia Pacific region. So we can say the maximum temperature, even during summers, is not reaching beyond maybe 30 degrees centigrade. So even in those kind of conditions, the PVB laminate is not able to sustain even its own self weight. Yeah. Now I would like to play the video for a Trosifol ES interlayer, which is sandwiched between the two glass layers, the same glass construction but with a different interlayer. It is ES. ES stands for extra stiff or structural PVB, and in this case, you saw we place these gunny bags on the top of the surface, but even then these were not able these were not sufficient to bring down the cantilevered piece of glass. Yeah. Okay, so when we talk about structural applications, you may have seen the glass is minimally supported, and when we say that the glass edges, these are exposed to the environment because they are minimally supported, and they are not getting framed on all the four edges. So it's very important um, to ensure that the laminated glass that you're going to use has a very strong durability against ingress of moisture, and when it is exposed to such conditions, it may have a tendency to get delaminated, especially if the interlayer is hygroscopic in nature. So it's important to ensure that the product or the interlayer that you're going to use for such application has gone through the rigorous weathering tests which are strongly recommended for such applications. So we have natural Florida exposure, which is a test going on for our laminate in laminated interlayers like sintry glass for more than 20 years. And also you can simulate such tests in the lab where you can expose the laminate to temperatures of from -40 to 82 degrees centigrade. Yeah. So although you can simulate the conditions in the lab, but there is a big debate always going on regarding the actual correlation between the test or between the outcome of the test results in the lab versus the performance of the laminate in the in actual use conditions. Yeah. So yeah, so you can like when you're using laminated glass for any of your projects, obviously you can't wait for such long durations. So you have to rely on the lab test, and I would say it's a kind of balance that you have to maintain between the two. Yeah. So when we talk about the open edge conditions, it's one of the parameters which is very important to look at for a facade consultant is the ESN number. So ESN number is the edge stability number of the laminate. How this is calculated, you can see the formula on the top right corner of your screen. So this is a formula for deriving the ESN number. Basically, what it means is like you are giving a higher weightage to any defect which is found in the vision area of the glass, and a less weightage number has been given to any defect which is observed near the edges of the glass. So which means there is some degree of tolerance for any defect which is observed, let's say near the from a distance of 1.6 millimeters from the edge. So that might be acceptable. Depending upon if the glass is getting framed or not. So I would recommend to go for an interlayer, especially when you have exposed edge applications, because there you can't afford to have any kind of defects. Otherwise, I mean, there will be a big compromise between between the intent of the architect when he wants to have a seamless view from the glass railings or whatever application it is. And especially if you're making use of an extra clear glass, there in some cases just for the beauty of the edges, extra clear glass is preferred. So you can't really take a chance, and we would recommend to go with an interlayer which has a proven durability against such weathering conditions. So sintry glass retains its ESN number of 0 after being exposed to the extreme weathering conditions in Florida, which is known for its high humid and high temperature conditions after more than 20 years now. So this test is still going on, and we do this observation every year. And now I think this 21st year is going on, and I think we will be coming up with the latest data sometime within this year. Yeah. And also here you can see the comparison of the stiff PUB and the Sentry glass and the standard PUB. You can see the standard PUB has its ESN number reaching close to 375 just after 5 years. And also the blue line that you see, it says the ESN number reaches up to 100 just after 5 years. I mean, the ESN number is a very well accepted number in the industry, and it is said that anything below 500 is considered a good number for the durability of the interlayer. But when it comes to open edge applications, I will recommend to go with the ESN number of 0. So you have a clear choice to make between the good, better, and the best. So here I have a quick comparison of standard PUB, structural PUB, and Sentry glass. As you can see, for Sentry glass, it stands completely different, completely stands out from standard PUB and structural PUB on all the parameters mentioned on the left-hand side. Whereas structural PUB, in terms of the post-breakage performance at room temperature and the structural properties at the room temperature, these are quite comparable to Sentry glass. But yeah, it has some limitations, and that is why it is it is classified as in between standard PUB and Sentry glass. Yeah. Then we talk about security applications, and security is becoming a big topic of concern all over the world because of different reasons. So we have sometimes terrorist incidents happening. So where the intention is just to make the occupants of the building, safe whenever there is a potential attack onto the building. It could be vandalism, or it could be an incident of terrorism. So there could be a blast happening outside the building, or there could be some shooting incident happening outside the building. So there are different country standards available for rating the intrusion resistance of a building of a particular glass that is being used for a facade application. So when we are talking about low levels of threat, the test is done as per the EN 356 standard. The test is done by dropping this steel ball, which is weighing 4 kgs, 100 mm in diameter. So that it is dropped repeatedly 3 times in a triangular pattern. And this glazing is given a rating from P1A to P5A. So you just vary the release height of the ball, and if this ball is able to make a penetration into the glazing, it is considered as a failure. And for higher threat levels, we have the threat levels from P6B to P8B, where the test is done with the use of a mechanized X. And so I have a video over here, which is for a test done on a piece of glass, which is required to sustain impacts from different types of weapons that could be used. So in this case, you can see this piece of glass was actually shot by 5 number of bullets, 7.62 mm bullet, and now it is being subjected to like 20 bricks. And now this man is trying to break the glass by kicking the glass using a steel-toed shoes. Now he's trying to break the glass with a hammer. So the intent is to make a penetration into the glass and enter the building, So here the purpose of using this type of glass is to make the intruder increase the amount of effort and the time that he has to take to make an opening in the glass. So by this time, it is expected that the alarm systems of the building, they will start and give sufficient time to catch that person. Yeah. So now he's trying with a baseball bat. I think that this video is pretty long, so I will just move it quickly to see that what kind of weapons there he has used. So in total, it took like more than 12 minutes to completely break the glass, but still it was not sufficient for this person to make a sufficient opening into the glass and enter the other side. Yeah. So this is for security glazings. The standard security glazings, they are making use of conventional materials like polycarbonate and the PVB interlayers. They have a very limited durability. The advanced interlayers like Sentry Glass, Spall Shield, they are known to reduce the weight of the glazings by 50%, and they are extremely durable because they can withstand high temperatures. Then moving on to acoustics, here we have a comparison between the standard PVB, standard single monolithic glass, and then we have PVB laminate glass and acoustic PVB laminate glass. So there is a clear difference of 3 decibels from standard PVB to acoustic PVB. Here, then we move on to the Trosifol colors. When you want to play with different colors, we have color interlayers available. 2 unique products that we have in our kitty, they are Trosifol Diamond White and Brilliant Black. These are the 2 interlayers which are 100% opaque. They don't allow any light transmission. I mean, the light transmission is 0 in this case. Yeah. So this is a project which has made use of the diamond white, and to achieve this kind of look, you have to do the ceramic fitting on the glass, but in this case, you see there is no optical distortion because with the use of diamond white, the architects were able to use annealed glass for this application. Yeah. Bird-friendly glazings, I think with the rapid urbanization, our cities are becoming concrete jungles, and they are making use of lots and lots of glass, and it is resulting in not so favorable conditions for the birds because they can't really make a difference between if the glass is too clear, they just collide with the building, thinking that there's a clear passage for them to move. And it is estimated that more than 1 billion birds, they actually get killed because of this just in the US. So the existing solutions, they are making use of this kind of ceramic fritted patterns on the glass. So the downside of this kind of pattern on the glass is you have to do the heat tempering of the glass, and which is a kind of compromise with the appearance of the glass, because you do any kind of heat treatment. First is the optical distortions. No matter how good the damping quality is, but there is some compromise. And at the same time, when you do this kind of ceramic fitting, you are making the glass weaker. Yeah. So we have a solution. We have this dot pattern getting printed on the PVB interlayer, which is available on PVB and Sentry Glass as well. So we do the printing on the interlayer itself, and this can be sandwiched between the 2 interlayers. And we have done all the necessary testing for this. So this is how it looks. So we have a comparison here this is how the glass looks when viewed from a distance of 1 meter. On the left-hand side, we have a standard laminated glass with a PVB interlayer. And when you move further from a distance of 2 meters, it looks something like this. And this is from 3 meters. Yeah. And this product has got the necessary certification from American Bird Conservancy. You can get more details about this product on our website, and you can get the brochures also. So this was all from my side. Any questions and comments? Yeah. Thank you very much.